Hey guys, welcome back to my YouTube channel. So for today's video, I will do a summary of Chapter 7, IP address. So IPv4 network addresses. So we have here the binary numbering system consists of numbers 0 and 1 called bits. So IPv4 addresses are expressed in 32 binary bits divided into 4 to 8 bit octants. So as you can see, we have here um, a 110 here. We have 11010001. This is the first octant, and the second octant, and third octant, and fourth octant. So every octant has a 8 bit. So let's move on. So IPv4 addresses are commonly expressed in dotted decimal notation. So mm, So we have a positional notation. The first row identifies the number base. So as you can see, we have a radix position number, calculate, and positional value. This is the decimal positional notation. And then we have applying decimal positional notation. We have positional value, decimal number, calculate, and then add them up, and we have a result. So the first row identify the number base of radix based on decimal is 10. Binary is based on 2, therefore radix will be 2. So second row consider the position of number starting with 0. This number also represent the exponential value that will use to calculate the positional value fourth row. So the third row calculates the positional value by taking the radix and raising it by exponential value of its position. Note. So let's move on. So binary to decimal conversion. To convert the binary IPv4 address to decimal, enter the 8-bit binary number of each octant under the positional value row 1 and then calculate to produce the decimal. So we will calculate here. So as you can see, we have here the 1 1, and all of this is 0, and then as you can see, we have a positional value. So we will add 1 1. So 128 plus 64 is 192. Then we have here same as the others. So decimal to binary conversion. So first we have here for we have here the example of binary conversion. So first we have 192. So we will 192 minus 128, and then we will add 1. The answer of the subtraction we will minus with the 64. If the 64 if the answer is greater than 64, it can be 1. You will be add 1, and then if the answer is less than 32, you will use a 0, and then same as the others. So you will apply it. So we have here network host. So as you can see, we will host portion. So an IPv4 address is hierarchical, composed of network portion and host portion. Network portion and host portion. So all devices on the same network must have identical network portion. So the subnet must help devices identify the network portion and the host portion. So as you can see, we have a network portion and host portion. So the subnet mask, unique IPv4, we already know it because previous um, chapter that I will tackle it. So IPv4 address compared to the subnet mask bit by bit for left to right. So A1 in the subnet must indicate the corresponding bit of the IPv4 address. So here's the figure. So logical end. So this is the basic for the logical end. So if 1 and 1 is equal to 1, if if 0 and 1, it is 0. If it has a 0, it also is 0. If 1 is, you can add 1. So here we have prefix length. And then so network host and broadcast address. We have types of addresses network. So 192.168.10.0/24, the network address portion is all 0. And then the first host address is portion is all 0 again and ends with 1. Same as go, we demonstrate. So as you can see, it is static. We already know it because I already said that in previous chapter. So again, unicast, broadcast, multicast, unicast, broadcast, multicast. So IPv6 network addresses. So IPv6 versus IPv4 has larger 128-bit address space. So 340 undecillion addresses solve limitation with IPv4 adds an enhancement like addresses auto configuration. So why is needed in IPv6 rapidly increasing internet population issue with NAT Internet of Things. So migration from IPv4 to IPv6 technique is a dual stack tunneling and translation. So IPv6 we have 1 to 8 bits in length, so every 4 bits is represented by a single hexadecimal digit. So hextet, an official term referring to a segment of 16 bits of or 4 hexadecimal values. So here's the representation of IPv6. So omit leading zeros. And then rule 2, we have a rule 1. In order to reduce or compress IPv6, first rule is to omit leading 0 in any hextet. Then we have rule 2. The double colon can replace any single contiguous string of 1 or more 16-bit segments. Consist of all 0. So again, unicast. So here's the unicast of IPv6. Single source IPv6 address, and then multicast. An IPv6 multicast address is used to single IPv6 packet and multiple destination. So anycast an IPv6 anycast address is any IPv6 unicast address that can be assigned to multiple devices. So we'll proceed that. Prefix length of IPv6 is used to indicate the network portion of an IPv6 addresses. The prefix length can range of 0 to 128. Typical IPv6 prefix length for most LAN is /64. We have a global unicast and link local unique local. These are globally unique internet routable addresses used to communicate with other devices on the same local link confined to a single link. used for local addressing within the site. Include that. So structure of an IPv6 global unicast address. So global routing prefix network portion of address that is assigned by provider, typically /48 subnet ID used to subnet within an organization. Interface ID equivalent to the host portion of IPv4 address. So dynamic configuration. So dynamic link local can be established dynamically or configured manually. Cisco IOS routers use EUI64 to generate the interface ID for all link local address on IPv4 interface. So as you can see here in the figure. So static link local addresses. So manually configuration of the link local address allows the creation of a simple, easy to remember address. So verify IPv6 address configuration. The command to verify the IPv6 configuration are similar to IPv4. So you can show IPv6 interface brief and show IPv6 route. So the ping command for IPv6 to identify the identical the command used with IPv4 except that the IPv6 address is used. Go up here. So there are two types of IPv6 multicast, assigned multicast and solicited node multicast. So reserved multicast address of predefined groups of devices. Then solicited node map to a special Ethernet multicast addresses allow Ethernet NIC to filter frame on destination. So we have ping testing, connectivity, remote host. So use ping to test the ability of host to communicate across an internet network. So we'll use the pinging. Then trace route, testing the path, trace route, utility that generates a list of hops that were successfully reached along the path. So round trip time, RTT time it takes a packet to reach remote host and from the response on host return. So asterisk is used to indicate host lost packet. So we have packet tracer, lab, exams mapping. Okay, so here's the chapter summary in chapter 7. So explain the use of IPv4 address to provide connectivity in small to medium-sized business network and configure IPv6 address to provide connectivity in small to medium-sized business network. So use common testing utilities to verify the test network connectivity. So this is the end of my video and I hope you enjoy it and thank you for watching and goodbye.